On March 25, 2011, in a sealed office in central Tokyo, a man named Shunsuke Kondo handed the Prime Minister of Japan a 15-page document. The Prime Minister was Naoto Kan. There was no title on the cover. It would be classified, buried, and denied for years. When the world finally saw it, governments would scramble to explain it away. It was a plan to evacuate the largest city on Earth. 50 million people. Tokyo, Yokohama, Sendai, everything within 155 miles of the eastern coast. Gone. For decades. Naoto Kan would later put it like this: "It was a crucial moment when I wasn't sure whether Japan could continue to function as a state." 2 weeks earlier, on the afternoon of March 11, 2011, the Pacific Plate had moved. Not a little. 80 meters in 6 minutes, releasing the energy of 45,000 Hiroshima bombs and producing the most powerful earthquake ever recorded in Japan. But the earthquake isn't the story. The wave that followed isn't the story either. The story is what happened in the 4 days after, when 3 nuclear reactors melted down, when a seawall built against a theoretical maximum failed catastrophically, and when a prime minister sat in a Tokyo office holding a document that asked, in the calmest possible language, whether the world's third largest economy was about to become uninhabitable. The story is also a question, because the seawall at Fukushima wasn't built carelessly. It was built to the exact height that the best seismologists on Earth had said was possible. They had run the calculations. They had drawn the hazard maps. They were wrong by a factor of 130. This is the earthquake that almost ended Japan. And this is the science that lied to us about whether it could ever happen. That sentence is going to take several minutes to unpack. If you want more stories like this one, the disasters and discoveries that rewrote a textbook, subscribe to Changes in Science. There's a lot more coming. To understand what failed at Fukushima, you have to understand what the world believed before March 11, 2011. Off the coast of Tōhoku in northeastern Japan sits one of the most studied geological features on Earth, the Japan Trench. It is the seam where the Pacific Plate dives beneath the Eurasian Plate at the pace of a growing fingernail, 8 centimeters a year. Slow, relentless, and according to the consensus of global seismology, predictable. For decades, scientists organized the world's subduction zones using seismic gap theory. The idea was elegant. Every fault has a personality. Some lock tight, build pressure, and release it all at once in catastrophic earthquakes. Others slip quietly, releasing strain in a continuous, almost gentle creep. The Tōhoku section of the Japan Trench was classified as the second type, a creeper, a safe fault. In 2007, the Headquarters for Earthquake Research Promotion, the official body responsible for Japan's hazard maps, published its definitive forecast for the region. The maximum possible earthquake along that stretch of fault was set at magnitude 7.7. This was not a guess. It was the work of hundreds of researchers, decades of data, and the most sophisticated seismic monitoring network on the planet. And it is the number that built Fukushima. The Tokyo Electric Power Company, known as TEPCO, had constructed the Fukushima Daiichi nuclear plant directly on the coast. 6 reactors lined up like fingers pointing at the sea. Around it, a wall, 10 meters tall, reinforced concrete. Designed using the official hazard map to withstand the maximum possible tsunami the science said was possible. 5.7 meters. The wall, in other words, was nearly twice as tall as the worst wave anyone in authority believed could ever reach it. But there was a problem, a buried one. In 2001, a team of Japanese geologists had dug into the Sendai Plain and found something disturbing. 3 layers of marine sediment stacked like pages in a book, each one the unmistakable signature of a massive tsunami that had pushed miles inland. The oldest layer was from the year 869, the Jogan earthquake, magnitude 8.4, possibly larger. The cycle between events was 800 to 1100 years. They published their findings. They warned the government. They were 1,142 years too late. The clock was already at zero. At 2:46 in the afternoon, on a clear Friday in early spring, Hiromitsu Shinkawa was at his lumber yard on the coast of Fukushima Prefecture. He was 60 years old. He was packing wood. The ground beneath him began to move. 80 miles offshore, at a depth of 20 miles below the sea floor, the Pacific Plate snapped. A 400-mile section of the Japan Trench released all at once. The strain it had been quietly building for over 1,000 years. The fault did not move centimeters. It moved 50 meters. In some places, 80 meters. The seafloor lifted 16 feet into the air. The seismic energy was so enormous, it shifted the Earth's axis 4 inches and shortened the planet's day by 1.8 microseconds. On land, the shaking lasted 6 minutes. In Tokyo, 230 miles away, skyscrapers swayed for so long that people inside thought they were going to topple. In Sendai, ceilings collapsed. In Minami-Sanriku, half a city's population would be missing by sundown. Shinkawa ran home. He had decided he needed to save his home, his belongings. Japan has the most sophisticated tsunami warning system on Earth. Speakers along the coast began blaring. Television stations cut to red alerts. The system worked exactly as designed, but the warning gave a wave height. 3 meters, it said. Stay above 3 meters. 40 minutes later, the wall of water that hit the Tōhoku coast was 13 meters tall in places, 45 feet. The height of a 4-story building. It surged inland for 25 miles, lifting fishing boats over highways, sliding houses off their foundations like furniture being rearranged, and carrying entire towns whole into the Pacific. In one prefecture, 1/10 of the population would be dead by nightfall. Shinkawa never reached the 2nd story. The wave took his house, and it took him with it. Somehow he surfaced on the roof of his own home, now floating in the open ocean. He clung to it as currents pulled him out to sea. He drifted past the wreckage of his neighborhood, past pine trees uprooted from the coast, past eventually the curve of the horizon. 2 days later, 10 miles offshore, a Japanese destroyer would spot a man waving a red flag he had torn from a piece of cloth. By then, the meltdowns had begun. 15 miles south of Shinkawa's drifting roof, the Fukushima Daiichi nuclear power plant was shutting down exactly as it had been designed. When the shaking began at 2:46, the 6 reactors performed their first automated function flawlessly. Control rods slammed into the cores. The fission reaction stopped. Backup diesel generators kicked on, doing what they were built to do, keeping cooling water circulating through fuel rods that were still extraordinarily hot and would remain dangerous for days. Engineers in the control room exhaled. The protocols had held. Then they looked at the cameras. 41 minutes after the earthquake, the first wave arrived. It topped the 10-meter seawall and kept rising. By the time it crested at the plant, the water was nearly 15 meters tall, 5 meters higher than the wall it had just rendered irrelevant. The diesel generators were located in the basements. They drowned in seconds. Without electricity, the cooling pumps stopped. Without cooling, the fuel rods began to heat. Reactor 1 reached critical temperature in less than 5 hours. Reactor 2 and Reactor 3 followed over the next 2 days. Inside each of them, the uranium fuel, heated past 3,000 degrees Celsius, began to melt through its own containment. On the evening of March 12th, hydrogen built up inside Reactor 1's containment building and exploded. The blast tore the roof off the structure and sent radioactive debris into the sky. Reactor 3 blew on March 14th. Reactor 2 cracked open on March 15th. Inside a control room with no power, no lighting except flashlights, and instruments that read radiation levels in millisieverts per hour that were rising into the thousands, the engineers of Fukushima Daiichi made a decision that became, in the years since, one of the most quietly contested moments of the disaster. They asked TEPCO headquarters in Tokyo for permission to evacuate the plant entirely. Naoto Kan, the prime minister, would later say that if that evacuation had happened, the cooling pools of spent nuclear fuel, sitting exposed to the open air with thousands of fuel rod assemblies inside them, would have boiled dry. They would have caught fire. They would have released into the atmosphere, in the calculation of one Japanese government report, between 10 and 100 times the radiation of all 3 reactor meltdowns combined. The plant wasn't evacuated. 50 workers stayed. They became known, around the world, as the Fukushima 50. And in Tokyo, the prime minister picked up the phone. The call went to a man named Shunsuke Kondo. Kondo was the chairman of Japan's Atomic Energy Commission, a nuclear engineer by training, the kind of bureaucrat governments turn to when the official answer needs to come from someone whose authority is impossible to question. When Naoto Kan reached him, 2 weeks into the crisis, the prime minister's request was very specific. Kan said, "Since things are starting to calm down, would you consider a worst-case scenario?" Kondo, in his own later account, was confused by the timing. If things were truly calming down, why would you need a worst-case scenario now? He agreed. He had 3 days. What he produced is one of the most extraordinary documents ever drafted by a modern government. 15 pages. No public announcement. No press release. Classified the moment it was delivered. Its existence would be denied for 10 months and only confirmed by the Associated Press after a Freedom of Information request in early 2012. The document outlined 6 escalating scenarios, ranked by severity. Each one began with a single failure at Fukushima, a fuel pool boiling dry, a reactor breach, a hydrogen explosion in the wrong location, and then walked, in the calmest bureaucratic language, through the consequence chain. The worst of the 6 was titled simply, "The case in which the situation becomes uncontrollable." If that scenario unfolded, the report stated, mandatory evacuation would be required within a radius of 170 kilometers of the plant. 105 miles. Voluntary evacuation would be recommended out to 250 kilometers. 155 miles. A circle that size, drawn from the Fukushima plant, reaches further than most people imagine. Within it lies Sendai, a city of 1 million people. Within it lies every coastal town from Iwate to Ibaraki. Within it lies the entire Tokyo metropolitan area, 35 million people. The largest urban economy on Earth, the 3rd largest city ever built by human beings. The report estimated this zone would remain uninhabitable for several decades. Naoto Kan read it. His advisors read it. They told no one. Publicly, the Japanese government maintained that mandatory evacuation extended to 20 kilometers, voluntary to 30. The United States, looking at the same data from a different distance, recommended its citizens stay at least 80 kilometers away. Germany's industrial giant Bosch asked the Japanese government directly, "What is your worst case?" They were told there was no need to worry. Years later, in an interview with Japan's national broadcaster, Kan would describe the moment with a flatness that is itself a kind of horror. "It was a crucial moment," he said, "when I was not sure whether Japan could continue to function as a state." 50 million people. the end of the third largest economy on Earth. A document so dangerous it could not even be acknowledged to exist. And only one thing standing between it and the actual world. 50 engineers in a building with no electricity, hand-pouring seawater into a hole that should not have been there. Fukushima did not melt down completely. The Fukushima 50 held. The seawater they pumped hour after hour with no certainty it would work cooled the cores enough that the fuel pools did not boil dry. The worst-case scenario in Shunsuke Kondo's report never came. Tokyo was not evacuated. But something else collapsed. In the weeks that followed, every seismologist on Earth began re-examining what their textbooks had said. The fault that produced Tōhoku had been classified as low risk for a magnitude 9. Not low probability. Low risk. The official Japanese hazard map had set its ceiling at 7.7. The actual earthquake was a 9.1. The energy difference between those two numbers is not double. It is not 10 times. It is 130 times. Seismic gap theory, in its classical form, did not survive the year. In 2016, the United States Geological Survey formally upgraded the Tōhoku magnitude from 9.0 to 9.1. The revision was not cosmetic, it was an admission. The seafloor had moved further, the energy was greater, and the models we had been using to forecast subduction zone earthquakes had been systematically underestimating their maximum size, possibly everywhere. The implications now stretch across the Pacific Rim. The Cascadia subduction zone, off the coast of Oregon and Washington, was once thought to top out near magnitude 8. After Tōhoku, it was re-evaluated. Scientists now believe Cascadia is capable of producing a magnitude 9.0, and the geological record shows it last ruptured in January of 1700. The recurrence interval is roughly 500 years. The clock, as in Japan, is already at the late part of the cycle. The Nankai Trough, off Japan's southern coast, has also been remodeled. So has the fault off northern Chile. So has the Aleutian. In every case, the maximum possible earthquake, assigned by the old hazard maps, has been revised upward. This is what the Tōhoku earthquake actually changed. Not just a seawall, not just an industry. It rewrote the ceiling on what the ground beneath us is allowed to do. The wave that hit Fukushima was 13 meters tall. The wave we now build for, in every coastal nuclear facility on Earth, is twice that. Because we finally believe it can come. Hiromitsu Shinkawa was rescued. His wife was never found. Naoto Kan resigned as prime minister 5 months after the disaster. He spent the rest of his career campaigning to shut down every nuclear plant in Japan. The 15-page document was finally released, partially in 2012. Most of Japan still hasn't read it. The Pacific Plate is still moving, 8 centimeters a year, slow, relentless. And somewhere along its length, under the Cascadia coast, the Nankai Trough, the Aleutians, it is building toward a number we now know is possible. This was the earthquake that changed science. The next one is already on its way.